Normalization. Hello guys, good evening everyone. So today we are going to discuss about normalization in a relational database management system. So normalization is a very simple process actually. So if the values is repeatedly available in a particular table, so that we have to delete, that we have to omit it. So that is called normalization. So normalization is the process of eliminating the redundancy as much as possible without losing the original data. So this is a tools of normalization. Normalization is achieved by two ways. One is lossless decomposition, another one is functional dependency. So lossless decomposition means we are dividing the table as much as possible without losing the original data. Then functional dependency means one attribute is dependent on another attribute in a table. So what is attribute? Attribute is nothing but the column name in a table is called attribute. So we will see deeply, okay, what is lossless decomposition and what is functional dependency. So first we go for functional dependency, right? So functional dependency is a L and relationship set of attributes within a relation to another set of attributes in a same relation. That means we will see one example. So ANR is one attribute, last name is one attribute. Actually, last name is determinant that is fully dependent on ANR attribute. So ANR is one attribute, last name is one attribute. So this both last name is fully dependent on ANR. So here functional dependency is deeply explained in one relational table. So IATA is a airlines. So remaining right hand side displaying is a airport names. So every airport compulsory register in one airlines. So Amsterdam Schiphol is registered in IATA. London Heathrow is registered in LHR. So all the airport is definitely belongs to one IATA. So this is functional dependency. So one attribute is dependent on another attribute in a table, that is called functional dependency. So here airport is fully functionally dependent on airlines. So this is the example of a functional dependency. So here one more example, one more case description. Airline reservation system. So flights are fully operated by carriers, passengers are reservation. So this both are example of functional dependency. So these are the another examples. Okay, right? So here uh, first we go for first normal form. These are the types of normalization. What is first normal form? So a relation is in a first normal form. First, all the values, it should be atomic values. What is atomic values? Atomic values means it is a single value. Okay, it not depend any other attributes. It is a single value. For example, here career contains both ID and full name. Departure and arrival contains both date and time. So there is not a atomic values here. So if you want to convert your table into normalization, we want to split up the columns. So first, what is the what is the need of normalization means eliminating the redundancy. So redundancy means repeated values in a table, right? So what is first normal form? So keep it in your mind. First normal form means atomic values. So we will see example. Okay, what is first normal form? First normal form, here we are representing in a um, diagrammic form. So passport, flight number, departure date, initials, last name, nationality, status, origin, destination, carrier ID, then carrier name, departure time, arrival date, arrival time. These are the attributes in your tables. IATA, town, airport, country. These are the many attributes presented in a table. So, what is the anomaly here? Anomaly means there is a problem. Flights without reservation does not exist. Carriers without flights does not exist. So, how to resolve it? We are decomposing the tables, right? So, here passport flight number departure date is we are decomposing, then I origin and destination we are decomposing, so we are getting the atomic values, right? So can you understand this? So first normal form means all domains should contain only the atomic values, single value. Okay, right, atomic values means single value. If there are any problems, if there are any anomalies in a table, we are decomposing the tables, right? So this is the first normal form, right? Then we are go for second normal form. So a relation is in the second normal form. The relation is should be first normal form also if all the non-key attributes are fully functionally dependent on primary key. So what is non-key? Non-key means key means primary key, foreign key, super key, candidate key. So non-key means it is not dependent on any key attribute. Without key, if any attributes are present in a table, that is called non-key attribute. Fully functionally, that key is fully dependent on primary key. Primary key means, as we know already, a primary key means it is a single value. Okay, so single value, it should not be null. That is called primary key. Okay. So what is fully functionally dependency? So here B is fully functionally dependent on A. The B is not dependent on B is dependent on part of A. So ANR is one attribute plus last name is one attribute. So both is giving the address attribute. So non-key attribute is dependent on key attribute. So for example, in one table, 5 attributes are there means one attributes dependent on key attribute. For example, in our student table, register number is a key attribute. Other attributes, marks, then your names, then your subjects. So everything is non-key attribute. So that marks your name is fully dependent on your register number. So that is the example of second normal form. So if all the attributes in a table fully dependent on key attribute, so that kind of relation is it is present in the second normal form. Okay, it is clear. So we will see example functional first normal form dependency diagram, right? So here you see a passport, flight number, departure date, origin, destination, carrier ID, carrier name, initials, last name. So what is this? These are the attributes. So passport is a one key attribute. So remaining initials, last name, nationality, all letters belonging to the passport. Same as flight number is one key attribute. Origin, destination, carrier ID, carrier name, all it is dependent on flight number, right? So here carrier ID is key attribute, carrier name is non-key attribute. So carrier name is fully functionally dependent on carrier ID. So this is how the attributes are dependent on another attributes. It is a one sample diagram, right? So what are the second normal form violations? So flight number is a determinant for destination. Origin, carrier ID and carrier name. So flight number is a determinant. That means flight number is a one key attribute. Destination, origin, career ID, and career name is non-key attribute. So this destination, origin, career ID, career name, all dependents on flight number. Passport is a determinant for initials, last name, and nationality. So initial, last name, nationality, all belongs to the passport. So same as flight number and flight number together. Okay, flight number together the status. So these are the second normal form violations, right? So how we are splitting up the tables? So here I can see you the I can show you the diagrammic representation. So flight number, passport. So these are the main key attributes. So career ID, career name, origin, destination, this all attributes are dependent on flight number. Same as town, airport, country, these attributes are dependent on IATA. Same as passport, flight number, and departure date. These three combining together, and we are making a one table. So, so why we are splitting up the table means, if you are splitting up the tables, we can remove the redundancy as much as possible. Okay, right. So this is the diagrammic representation of splitting up the tables. Okay, so I think this is understand you. So once again I recall all the topics what we discussed today. So first I just recall what is a normalization. Normalization is the process of eliminating the redundancy. Redundancy means repeated values, right? So two tools are there. One is lossless decomposition, another one is functional dependence. Lossless means without affecting the original data, you are removing the data. Functional dependency, one attribute is dependent on another. Attribute is column name is called attribute. So one attribute in a relation is dependent on another attribute, that is called functional dependency. So functional dependency means last name is dependent on A and R. So this two is a example of functional dependency. So same as IATA and airport. Airport is compulsory dependent on one airlines. This is one example. Then another one is airline reservation system. This is also examples. Okay, then first normal form. First normal form means you clearly keep it in your mind. All domains contain atomic values, right? So what is the solution for all the tables should be in normal form? First, one, split up the columns. So this is the diagrammatic representation we will see just now. We saw just now, right? Second normal form. All non-key attributes are dependent on key attribute. Key non-key means without any key. Key attribute means primary key. That is called key attribute, right? So here is the functional dependency diagram. Thank you. We will see remaining sessions in a next upcoming class. Thank you. Thank you so much. Thank you, guys.